Sir.
Okay, so once again, a very good afternoon to everyone. Welcome to the tutorial class, lecture class for CIN535. Okay, so we'll go over the lecture notes very quickly. Now, in just a while back, we disconnected due to network connectivity. I had already gone over lecture slides 1 to 6, but we'll go over them once again. So thank you for your patience, those of you uh, who are bearing with me for going it over once more. So in this set of lecture notes and lecture slides, we're looking at making multimedia. Okay, an overview. What we'll be doing is we'll be looking at some of the stages of a multimedia project and what sort of hardware, software, and authoring systems one need to ensure or one needs to have when they are creating a multimedia project. Stages of a multimedia project. The very first stage of a multimedia project is planning and costing. The needs of a project are analyzed by outlining its messages and objectives. A plan that outlines the required multimedia expertise is prepared. Now, what happens in the planning and the costing stage is that the project leader, whoever is leading the project, would try to get the requirements of the clients, and based on that will plan how he or she would carry out the work to successfully complete a project. Now, a project in general terms has a start date and an end date. If a project is not something that is continuously ongoing, if something is an ongoing is on a ongoing phase, so it's not a project, it's a process. A project generally has a start date and an end date. Okay, that means it needs to start at a specific date and finish, bearing into the fact in mind that each extra day would mean additional costs. So in the very first stage, the client's requirements are seen, the client's requirements are met, and based on that, planning and costing is done. So after planning and costing based on the requirements that are given in by the clients, so the person who is leading the project or doing the project would actually go and start designing and producing the multimedia project. Now, multimedia projects, it could be a wide variety of things. It can be a website, it can be a brochure, it can be it can be a banner, it can be even a product which is kept on the show glass of a particular outlet, anything as such. Now, in the designing and producing phase, it is an iterative process. When we say iterative process, that means something that repeats over and over. Now, why? Is because when you are generally creating a product or when you're creating a project, you need to get continuous feedback from the client. So if your client does not agree to certain terms or certain things that you have done with the multimedia project, you'll have to revise it. Okay, the example that I mentioned earlier, and I will repeat it, is basically, let's say I am making a website for my client. Let's say my client is Izal. Okay, by the way, Izal is one of our participants here in the class. Thank you, Izal, for joining us regularly in our classes, and thank you to all of you as well. So let's say Izal hires me to make a website for him. So first of all, what I'll do is I'll try to get all his requirements and I'll make the website accordingly. So let's say if I make a portion of the website presented to him and then he says, no, something is wrong with the homepage. I want the banner image to be floating or the banner image to be moving. So I start and make a website and the banner image is moving now. Then he says, no, I want some more changes. Now, for me as a developer, I'll have to do it. Why? Because he is going to make payments for it. So my entire motive over here is, first of all, to deliver the project on time with the appropriate costs, and moreover to meet the complete requirements of the client. It's not that when your client leaves and after 2 or 3 months he or she is very dissatisfied. Now he or she needs to be satisfied, because word of mouth, that's how the concept works. That's how you market your own self. So if you're a good website designer or if you're a good multimedia producer, you do good work, people will talk about you, you'll get more and more jobs. Okay, after you have basically designed and produce your multimedia project, it needs to be tested. So when you are testing it, it needs to meet the very first set of requirements that was specified in the planning stage. Moreover, your client needs to be very, very happy. Okay, if your client is happy, satisfied, that's what needs to be done. If your client says no, something is wrong, then you have to go back to your designing and producing stage. Now with delivering is about, in terms of our website, it's about you are trying to make the website go live. If you're making a brochure, you print it down, pack it up, and give it to your client. If you're making a banner, so you'll make the banner, print it out, and give it to the client. Okay, so delivery is the very final stage. Now, what do you need? The intangibles. Intangibles come from the word tangibles. When you talk about something is tangible, something that you could touch, you could feel, you could see. Intangibles is quite comparatively opposite to it. In other words, something that you cannot touch, something that you cannot see, something that you cannot feel. Now, intangibles are something that you experience, something that you live in the moment, kind of thing. Okay. Now, creativity is in a multimedia project. Being creative implies knowledge of hardware and software. Now, very true. Let's say if I give you a Apple-based computer with the best kind of softwares, the best Apple computer in the world with the best software, and I tell you to create a multimedia project. Now you have sufficient knowledge in terms of creating a multimedia project, but you have no knowledge how to use a Apple Macintosh computer. By the way, Apple Macintosh computer is quite different from what you're using in Windows, and you have no idea of the software that is given to you. Now you won't be able to be creative. Why? Because you will be just working with basics. However, if I would ask you to go and do something in Photoshop or photop.com, now you have some sense of idea compared to someone who doesn't, so you'll perform better. Your creativity level would outshine. So that's why intangibles, you need the creativity level, and at the same time the knowledge of hardware and software. Organization. Now, organization here does not mean a company or a business. Organization means how well do you organize yourselves and how well do you organize the assets that are going to be used in the multimedia project. Now, some of the examples given there is you need to organize your skills well, you need to organize your time well, you need to organize your budget well, you need to organize your tools well. Moreover, you would also need, okay, moreover, you'll also need to ensure that you need all the resources very, very properly. Now, with assets, okay, we're looking at things such as, give me a second, people. Where's this? Okay, now with assets, what you're looking at graphics, you're looking at sound, and many times graphics would mean images. Now, if you're working with videos, if you make, remember, a YouTube video is also a multimedia project, sort of a multimedia project, because you are able to do a lot of things. So when you're looking at graphics, generally you include images, you have sound, you have videos, and so forth. Now, how do you use them and how do you organize them on a multimedia project is also very important. Now, you cannot overload your multimedia project with a lot of things. So when you overload, what happens is that your project will look very just like you're trying to push in so many things in a box and the box tears off. Okay, in other words, you will not make it look good. Okay. Now, moreover, a standardized file naming procedure should be followed for precise organization and swift retrieval. Now, what it means here is when you are giving in your file names, okay, try to give it in such a way that you yourself are easily able to locate it. For example, let's say you have created a Photoshop-based graphic, and you keep on changing it. For each and every change, you may label it as, okay, project 1, revision 1, project 1, revision 2, revision 3, revision 4, and then project 1, final. So you know, okay, this is the final outcome, and this is what I started with, this is what I have with. Okay, so that becomes very, very important. Now, with communication, okay, communication among the work group and client is essential for the efficient and accurate completion of your project. Use quality equipment and software for stable and fast networking of the work group. Okay, communication is about how you talk to people, how you allow things to pass through in a medium and get the information across to the other person. Okay, now generally when you are working on multimedia project, and if it is a very big project, there's a likely chance that you'll be working in groups. So how do you lay out the information to the other? How do you organize yourself so that you are dividing your work very, very effectively? Okay, so that is where communication plays a very good role. Now, what do you need? Okay, when you say what do you need over here would indicate as in terms of the types of hardware that you need. The most significant platforms for producing and delivering multimedia projects are Macintosh operating system and Microsoft Windows. The Macintosh as well as Windows PC offer a combination of affordability and software and hardware availability. Now we generally have two platforms, two major platforms. We have Linux as well. Okay, Linux could do a bit of graphic work, but what happens with Linux is basically for networking. You have Unix as well, that's also similar to Linux. I don't know if you've ever used Linux or Unix. Probably if you want to have a look how they work, you can always download them up, get a virtual PC software installed in your computing system, and then test them out, how it looks. Or you can always go and have a look at it in the YouTube videos. Okay, but the major platforms are Apple Macintosh and Microsoft Windows. Now here's the thing, I've used both operating systems, and generally when you're working with graphics, I would say Macintosh operating systems or Apple-based systems, they have the lead. In other words, they work better with graphic work. Windows also, but the difference between the two is this. With Windows, you have a lot of moving parts. Your processor comes from a different company, your sound card comes from a different company, your video card comes from a different company, and all the different drivers are owned by different companies. And when you load them up, okay, so there's a lot of different moving parts. Whereas with Macintosh or Windows-based operating system, is just a solid piece. You don't have a lot of moving parts. It's just like this. Remember, let's say if you're trying to do a work, okay, if you're trying to complete a task at work and you have to walk 10 steps every time to perform a task. So the person who walks 10 steps may take about 5 seconds to get something done. And there's one person who just needs to stand at a particular place and do the task. So that person takes about 1 second. So there's a difference, right? So the one who is walking is the one who is taking more time. Generally, same thing here. With Windows, we have a lot of moving parts. So therefore, the processor speed is a bit slower. With Apple Macintosh, probably the same level of speed, but things will get processed quite faster. Okay, so that's the difference. Remember this, both the operating systems, they have available hardware and software sold in the market here, even here in Fiji. You will be able to find all the necessary hardware and software for both the platforms. It's just that Apple is bit expensive. Secondly, over here in Fiji, there's a trend of us using a lot of bogus or a lot of those softwares which are more like pirated kind of softwares. Okay, it doesn't work in Apple. Okay, so you'll need to buy it. So that's where things get a bit expensive. But in countries whereby they treat all these things very, very fairly, for example, the States or even in Australia, okay, where they would need to go and buy the softwares and then use them accordingly. So they would prefer to buy something from Apple. The cost isn't as that much. Okay. Now, moreover, what do you need in a hardware continued? Okay. Now, detailed and animated multimedia can also be created on specialized workstations from Silicon Graphics and Sun Microsystems. Project must be tested to ensure proper performance in all target environments. Okay, let's ignore this slide. Now, Windows versus Macintosh. The Microsoft Windows operating system can run on assemblages of hardware from countless manufacturers. What it simply means over here is that Microsoft Windows platform, it can run with a lot of multiple manufacturers. And that's where the problem is with the speed, because they can actually accommodate. Now, it's a good thing they can accommodate a lot of different types of manufacturers. So you have options to buy cheap ones, quality ones, and expensive ones. But with Apple, okay, what happens is that you can only use an Apple-based product with an Apple computer. You cannot have any brand of keyboard and then plug it to an Apple computer and it may not work. Okay, it will not work. Forget about may, it will not work. They will need their own set of keyboards. You cannot get a graphic card and plug it in into a Apple unless and until it is an Apple based graphic card. With Windows you can do so. Okay, so that's the major difference between the two. Now, networking Macintosh and Windows computers, okay, so there are two common ways in which you can have networking, either through local area networks. You can have MANs and WANs as well, okay, and you can also have client server software which allows computers to communicate. By the way, LAN is local area network. There is a smallest type of network. LAN network basically means networking within a building. For example, in FNU lab. MAN, which is metropolitan area network, these are networking between buildings. For example, in FNU, you have, okay, most of you are from Radaka campus. So let's say you are seated somewhere near the old lecture theater, and then there's someone who is seated somewhere in GP lab 2. Okay, so if you want the computers to communicate, so metropolitan area network works in that case. And WAN is a network that is countrywide or worldwide. For example, our mobile phone networking services is countrywide. Okay. Now, wide area networks, okay, I think I've already explained this. Okay, now connections, there are different types of hardware connections that you could get it set up in your platforms. Okay, when I say platforms, there are two platforms, Macintosh and Windows. Now, small computer system interfaces, okay, that is SCSI, okay, and then you have integrated IDE, integrated drive electronics. You have universal serial bus or USB, and then you have Firewire IEEE 1394. I think most of you will be familiar with this. You should also be familiar with this if you're quite familiar with the individual hardware parts that are inside a computing system. Like a CSCI, I'll tell you what that is also. And Firewire, I don't know if you have seen that connection or generally it comes with Apple-based computers. Okay, CSCI, okay, so small computer system interface, connects internal and external peripheral equipments and devices. It's preferred for real-time video editing, networking servers, and situations that require mirroring. Now, CSCI are those ports that you have in your computer system that are used to plug in networking cables. Okay, CSCI ports. IDE connections are also known as Advanced Technology Attachment, ATA. These are usually internal devices such as hard drives, CD drives, and DVD-ROMs, ROM drives rather. Now, IDE, if you have opened up a Windows-based computing system, if you open up the system unit, and if you see the connections, the pins that are in a computer's motherboard, and it plugs in the hard drive, okay, in it. So those are IDE connections. Now we don't have IDE, we have SATA connections, SATA, okay. SATA connections are way more faster than IDE. Why? Because with IDE you have pins, it carries close to about 32 bits per pin, whereas in SATA there's no use of pins. Data transmission rate is way more faster. You're looking at somewhere about 86 bits of data transmission rate at a point in time. Okay. USB, you're familiar with USB flash drives. Okay, so remember, USB, universal serial bus, it is the name of that port. Okay, the device that you carry, okay, we call it USB flash drives or flash sticks. Okay, it's called flash, means memory. By the way, the other word for flash is memory. So universal serial bus flash or memory sticks. Okay, so what happens is that these devices, they store data for you and you plug it into USB ports. Okay, now what's the maximum number of what the maximum memory of flash drives have you seen or used? Anyone? Maximum memory? I've seen 1 TB flash drives. Has someone seen anything more than that? No? Yes? Anyone? You have seen anything more than 1 TB? No. Okay. Now, moving on is Firewire. Now, Firewire is basically just like we have connections for USB in Windows. They have Firewire connections in Apple-based computers, still used till now. Okay, the industry standard and provides support for high bandwidth serial data transfer, particularly for digital video and mass storage. Can connect multiple computers and peripheral devices peer-to-peer. Now, peer-to-peer, it is a simplest form of networking. That means one PC is directly connected to the other. In other words, you have a computer set up in one table. So and another computer on another table. So what you do is you have a networking cable. Let's say you get 5 or get 6 cable, the blue cables that you generally see in our networking or in our computing labs. So take the cable, plug it in the networking port of one computer and the other end onto the port of the other computer. So those two are connected to one another and they form peer-to-peer network. Now, peer-to-peer network is not so safe, okay, but it works in an environment whereby you are working in a personal environment, let's say at home. So one of your computer devices does not have that much of memory. So what you can do is, instead of buying a brand new flashy hard drive for about $179 to $200, so what you can do is you can get a network cable, get the cables hooked into both the computers, and based on it, what you could do is you can get some configuration done and you can share resources. You can transfer files, or let's say if a file is in computer 1, you can access it from computer 2. If there's a folder in computer 2 and if you want to access it, you can access it from computer 1 as well. So those are part of peer-to-peer network. Now you'll be learning more about this in CSC 626 networking fundamentals. Memory and storage devices. Okay, this is pretty simple. When you talk about memory, you're talking about space in your computing system. Now, generally, we have two basic type of memories. We have RAM and ROM. So which one is permanent and which one is temporary? So RAM is permanent or temporary?
Temporary.
Temporary, yes. So whatever is stored in RAM, and if you would restart your computer, so when you restart your computer boots up. So when it boots up, whatever is stored in it, it flushes out. Okay. With read-only memory or ROM, this is a permanent memory. Most of the things are stored, the basic tiny things are stored in ROM. For example, your computer's clock. Okay, the clock time, some basic sort of memories that we'll be discussing in the next few slides. Okay, now RAM enables the simultaneously running of many applications. Okay, it temporarily holds the data. For instance, when you're working on Microsoft Word, when you're making some changes to a document, so that is being kept off until you save it. The moment you save it, it goes back. Sorry, it's saved. The moment you save it, it releases the memory. Another thing that I could give an example of, let's say you undo or redo something. Okay, you go a step forward or a step back. Now this is some form of things that RAM generally does. With a ROM, it's non-volatile, meaning it's permanent. So a BIOS program that boots up the computer resides in the ROM. BIOS, basic input and output system. So what a BIOS program does, it goes and tests whether all your hardware and software is working properly or not. If you want to test it out, probably if you have a computing system at home, a desktop computing system, take out the keyboard and then it will give an error, no keyboard found. So that is the work of BIOS. So ROM is responsible for holding that BIOS program into your computer's memory. Now you have hard disks. Now we have hard disks, which is said to be non-removable mesh storage devices, and generally they have large data storage capacity and data transfer speed. Okay, now hard disks are non-removable. You cannot remove hard disks. The moment you remove a hard disk from your computing system, what happens is that your computer will not work. It will give an error. Why? Because normally the operating system is stored inside your hard disk. So without a hard disk and the operating system, your computer is just a empty shell. Okay. Now, you must be thinking, okay, why non-removable? We have removable hard disks now. Those are called external hard disks. There's a big difference between hard disk and external hard disks. Why? External hard disks, you don't need to plug it into your computer system. It does not hold your operating system, whereas a hard disk does. The connection is different. With a hard disk, you have IDE or SATA connection. With a normal external hard disk, you have a universal serial bus or a USB connection to it. Those are some of the differences. Similarities, both have high storage capacity, and the data transfer rate is quite faster than of a USB flash drive. Talking about USB flash drives, they also call it as thumb drives. Okay, why thumb drives? Size of your thumb. Okay, now small storage devices that can be integrated with USB or FireWire devices can store 8 megabytes. Now 8 megabytes was something that was used during my time. Okay, we had flash drives which was 8 to 10 megabytes. Gradually it increased to 16 megabytes, and then from there 32, and then we had, I think, 128 megabytes, and then 256, 512, and then 1 GB came in somewhere about early 2000, not 2000. Yeah, early 2000, somewhere about early 2009 or early 2008, somewhere around that. Now we have our flash drives or thumb drives in terms of 1 TB or 2 TB. I've seen them around. Okay, now it's more reliable than disk drives. Why more reliable? Less moving parts. Okay, it's just a memory stick inside it, a chip. So the chip basically is not a moving part. Okay, with a hard disk, you have a disk, you have a disk rotator in it, you have a disk actuator in it. So what happens with that? With the hard disks, generally a lot of moving parts, there's a likely chance that if a dust settles in, it may disrupt the operation of a hard disk and crash. Small printed circuit board encased in study metal or plastic. You know how that's how our flash drives are, either it's in a plastic form, or whether it's something in form of a metal. It's usable, trendy, and convenient. I am not so sure how trendy it is now, okay, but it is usable and also very easily losable as well. Why? Because it's so small, sometimes we tend to forget it here and there. Now, I think with our students in Lodaka campus is quite fine. I remember back in about 2015 when I was teaching in Namaka campus. So that was a time whereby I used to collect about 9 to 10 flash drives per day. People used to forget a lot of them. The reason being why it's becoming less, because a lot of you started using online storages, for example, Google Cloud, OneDrive, and so forth. And also the university offers close to about 15 GB of free space on Google Drive. So if you have a personal Google Drive, that's 15 GB there, and the university offers you 15 GB as well. So 30 GB is quite enough for you to store a lot of things. CD-ROMs. Now, I will not go over CD-ROMs and DVD-ROMs. These are old technology, and I think we've also gone over them in the previous set of slides. But just notice that this is also one form of a storage device, and multimedia projects can be stored in there. Now, there's two ways in which you can store in a CD and in a DVD, is either burning it or saving it. Saving it is just like what you do in your flash drives, but with saving it, you need a DVD minus RW rewritable kind of discs, and with a normal recordable disk, you'll have to burn it up. So once you burn it, you cannot store in it anything else. If it's rewritable, you burn it, you can rewrite the files over and over again. Okay. I don't know how many of you have actually gained enough experience in using CDs or DVDs, CD minus R, CD plus R, CD, RW, and all those things, okay? Because technology is getting obsolete. Nowadays, mostly a lot of things are going either on flash drives or external hard drive or the online means of storage. Now, input devices, we have optical character storage, okay, OCR device that converts printed matter into ASCII text files. Voice recognition systems recognize spoken words and commands. Microphones and cables that are used to capture audio. And we have digital cameras used charge coupled devices, CCD, to digitally capture images. Now, optical character recognition, what it does, it converts a printed text into an ASCII text file. Now, ASCII, American Standard Coding for Information Interchange. Now, what happens is that you have a print, something written in English is converted into a language that your computers can understand. Optical character recognition. Voice recognition systems, you speak and the computer writes it for you. Okay, with us, we have a big issue because of our accent, our way we sound. Okay, generally, a lot of computers are programmed into American standard, so the use of R and how they pronounce, even in British English, is quite different from American and very different from what we speak. So most of the time, our computers may not recognize what you're saying, but if you eventually use it, let's say for a month or so, you will understand how the computers read these specific words. Output devices, output, that means generally when here how you can produce your multimedia in the way, in a mean that people can actually see it or view it. Okay, now you can produce your multimedia through the use of speakers if it's an audio based multimedia. If many multimedia developers use more than one monitor by adding additional display adapters to the computer. Yes, preferable, and I would say it would be a wise idea if you're doing something or working with graphics. It's good to have multiple screens. Why? Because it allows you to equally share the workspace. And I think we've also learned that when we were working with photop.com, okay, or the very first few set of lecture slides. Now, other form of output device that we have is projectors. Okay, projector is normally used to accommodate for a large number of people, and you have experience in watching things via projector. Now, just in case, imagine this: when let's say we are in a lab, so your lecturer comes in and starts teaching you through your computer screen, uh, and you don't have a projector. It's difficult to stay concentrated, right? So that's why we have projectors, generally to accommodate a large number of people. And then we have colored printers. Now, color printers and black and white printers, if you have a picture which is in black printed and you have another picture which is colored printed, so if you'd ask people to go and choose one of it, they'll normally go and choose a colored one. Why? Because it's colorful. Okay, colors bring life to a lot of things. If you create a advertisement on TV, it is if it is completely black and white, hardly people will go and watch it. If it's in color, people will take big interest in them. uh okay, now I'm going a bit faster than usual today is because my internet connection is seems to be unstable. How about yours? Is it same as yours, or is it just mine? Fayum, how's your internet connection that side?
So it's a bit bad.
Yes, it's a bit bad. Yeah, even for me as well. Normally, when we close, I'm using the same internet connection as every day. I had a class just before you guys was seems to be work. It was working fine, but it's just that this class it's a bit unstable. So I'm going a bit faster so that I can finish this quickly, and then so that we don't have another disconnection in the middle. Okay, so if you feel I'm going too fast and if you have questions, feel free to ask me questions later onwards. Okay, so that finishes up of what we wanted to cover in this week's lecture class. Now, your lectures are small. Also, moreover, it's some weeks you have something that is very, very complicated and some weeks is very easy. For example, this week. Okay. Now, what I would suggest is for you to pay keen attention to me in next week class. And what we'll do is I'll quickly go and review all the things that you need to know in your lecture notes. Now, you don't have final exams, but you have a short test, which will be coming up somewhere around week 12. Okay, so I will tell you what things are important, because with your short test, I'm testing you on your theory, which would be about 50% of the short test, and the other 50% I am testing you on HTML and CSS. Okay, is there any questions or any queries from anyone? Any questions or any queries from anyone? No. If no questions or no queries, I didn't want to finish the class this quickly because I wanted to discuss some more things. Remember last week I gave an exercise, but internet connection at the moment is a bit unstable. So let's finish it off here, and tomorrow's lab class, we can talk more about those exercises. Is that fine with everyone? Is it fine with everyone? Probably just, yeah, just say yes or no. You can drop me in. Okay, thank you. All right, so this is where we'll knock off
Yes,
for
so
today. Okay, this is where we'll knock off for today. So thank you very much for joining in. Tomorrow's class, 9 a.m. Be in tomorrow's class, because tomorrow we'll be focusing on very important aspects of HTML. Okay, so I'll see you tomorrow, and tomorrow's class is going to be interesting as well. Till then, take care, stay safe. Thank you. Goodbye, everyone.